Welcome guys, we're going to go ahead and derive another additional useful trig identity, and we're going to begin with the Pythagorean identity here, and we are going to start by dividing each term by cosine squared theta. I should really be saying cosine theta squared, but the way it's written, we put the 2 between cosine and theta. Now we're going to go through each term and see if we can rewrite it a different way to make it simpler. And we're going to do one additional step that you don't see just to make sure you understand the substitutions that we're making. So the first thing I'm going to do is I'm going to rewrite sine squared theta over cosine squared theta as sine theta over cosine theta squared. The next thing I'm going to do is I'm going to simplify cosine squared theta over cosine squared theta and write that as 1. And then 1 over cosine squared theta I'm going to write as 1 over cosine theta in parentheses squared. Now we're going to see if we can make any substitutions using identities that we have already learned. So the first thing I'm going to look at, sine theta over cosine theta. We have an identity that says tangent of theta is equal to sine theta over cosine theta. So we'll be able to replace sine theta over cosine theta with tangent theta. We have another identity that says 1 over cosine theta is equal to secant theta. So we can write this as secant theta squared. Now to rewrite it the way that you will probably see it, we'll write it as tangent squared theta plus 1 equals secant squared theta. So this is one of our additional identities. Sometimes you will see 1 subtracted from both sides, and you can produce another identity that says tangent squared theta is equal to secant squared theta minus 1. And there you go.